Greetings everyone, this is Ashish Sharma and today I'll introduce you with an interesting project that is sustainable cooling system. But before I go on to these major project, I want to introduce you with the global scenario we're dealing in. We are living in a global warming condition, but one of the major reasons is air conditioners we are installing. And to the matter of fact, 5.6 billion air conditioner units will be installed by 2030, which exact number today is 1.6 billion. That means we are increasing our hydrofluorocarbons, and which is more hazardous than CO2. To the matter of fact, Qatar is now adopting the outdoor air conditioning, which means that we are killing our own environment by ourselves. That means we are using air conditioners to deal with the heat generated through air conditioners. That is not a sustainable solution. So I have come up with a solution which combines of two sustainable products, that is cardboard and PLA. Cardboard, I've used the quality of the cardboard, that is air permeability, and the PLA which gives the strength to the structure. Current social materiality is packaging and sorting, and for PLA it's 3D printing. So initially I've experimented with a cardboard. I stacked them together to develop the scale air ventilation system, tried the horizontal orientation for the flow of air, which was not pretty good. So I have tried for the vertical one and experimented it on a partner. Then thirdly, cardboards have a good water absorption capability which can be used for the extra cooling. So I have stacked them up and introduced the limited water, and then you can experience a cool air. Then fit the cardboard in the PLA skeleton to develop the stable structure. Afterwards, I've experimented with the PLA, and for that I've collected the scrap PLA, not the fresh one, from the 3D printing space, that is the UNSW maker space. And secondly, first of all I tried to develop the 2D to 3D models so that I can get an idea that how to create an actual structure for that. Then I heated the PLA with the home iron and gave the shape of the outer walls, base, and the ceiling. I've curved the edges of the walls so that I can stick them together. Reheated, compressed the PLA shape to give the wavy structure for that. I'll explain the reason to you later. And finally, I introduce you to the final product and the concept, that is sustainable cooling and ventilation system. So now this product can be used in the rural areas for the initial phase, which are deprived of the electricity or air conditioners. The cardboard corrugations work as a condenser, so we are actually using the corrugations through the air permeability. As the air comes in, the air condenses and gives you a cooler air. So it balances the inner room temperature even if the outer temperature is humid. And the PLA is used as a skeleton which gives the strength and stability to the product, and in the place of windows. So the material used for the water system is placed at the top of the product so that the limited water can penetrate to the product, make the air more cooler, and you can feel more good. And finally, I've seen this technology to be used. I was surprised to be seeing this technology to be used in the ancient times, which were known as the wind catchers. They are the traditional wind catchers, and they run on the non-fossil energies. They are totally dependent on the outer environment. As much as the outer environment is hot, so the inner environment is cool as much. So how it is related to our material, as we are vertical corrugations are working as same as the vertical corrugations in these buildings. So this was a surprising element for me, and I introduce you to the new social materiality I want to try to introduce. As you can see in the image, where I want to use this on a scale. So air permeability and ventilation is the new social materiality, supporting frames, and the wavy texture is to represent the rural areas, and no perfection is required to make these materials, so everyone can make this material. So I am kindly focusing on reusing the excessive materials which are contributing in global warming, cardboard in methane release, and PLA in soil acidic levels. So how can people use it? It will be available in the 10x size as the current model, and they can be used instead of the windows, and the PLA structure will be fixed in that. And whenever the cardboards are not enough good for use, you can easily remove it and fix the new cardboard set into that, and you are done. No expert professionals are required for installation or uninstallation, and you are good to go. You are actually contributing to a good future, and you're not actually using the electricity to run your air conditioners. So that's my project. I hope you like it, and hope to see you soon all. Thank you.